Hello, ladies and gentlemen, and these are the notes for section 3.3, the first derivative test. Again, a very important section, one of the most important sections that we're going to be running into in these next couple of weeks. Ladies and gentlemen, the first derivative test indicates if a function is increasing or decreasing on an interval and will help to justify where a function increases and decreases. The first derivative test, however, is not the justification itself. It is merely a tool to help you explain where a function is increasing or decreasing. And remember, feel free to pause the video anytime you need to if I am going too fast. Ladies and gentlemen, let's consider what is an intuitive sense of increasing and decreasing. And this fall, you proved to me that you all do have a great inclination of what it means to be increasing and decreasing. From pre-calculus, a function increases on this interval and increases on this interval. As x increases, y increases. That's what pre-calculus teaches you. Okay? And similar for decreasing, as x gets bigger or increases, y decreases. This indicates a decreasing function. Okay, so that's the intuitive sense. And if you understand that, if you say, oh yeah, this function is going down as you go to the right, and this function is going up as you're going to the right, you understand increasing and decreasing. That's great. But on the test, it's not enough to say, hey, it's going up and it's going down. You know, saying x increases and y increases is not a justification for increasing. It shows that you understand what increasing means, and if this was a pre-calculus test, you would get it right. This is a calculus test. So we need the first derivative test to help us justify. Let's look. According to the first derivative test, a function is increasing if the derivative of f of x, or f prime, is greater than 0. So it is increasing if f prime of x is greater than 0. Another way of saying this, f prime is positive. A function is decreasing if f prime of x is less than 0. Again, associate decreasing with a negative derivative. Okay? If f prime of x is equal to 0, according to section 3.1 that we just covered, x is a critical number. Okay? Now, we have a critical number, and at that critical number, things are happening. Okay? And, of course, since 0 is neither positive or negative, it's not increasing or decreasing at that point. But we'll talk about that when we do some examples. Especially with end behavior, we also consider where f prime of x does not exist. Remember, we could have positive derivatives, negative derivatives, and zero derivatives, but we can also have one where the derivative does not exist. Here's a simple example. Let's let f of x equal x squared. We all know what x squared looks like. There's been pictures of x squares, and it was on your summer packet. So it was on the packet we did at the beginning of the school year. So you should be very familiar with x squared. First thing I want you to do is to find the derivative. Well, the derivative of f of x is 2x. Second, you need to set the derivative equal to 0 and solve for x. This will help us find our critical numbers. 2x is equal to 0 means x equals 0. X equals 0 is a critical number. Okay? Third, draw a number line labeling all critical numbers. In this case, we only have one critical number, and that is 0. Okay, this is going to be our f prime table, which is also going to be called our f prime test. Okay, again, pause the video, rewind if you need to. Next, fourth, we know that the value of f prime at 0 is equal to 0, and that's why I put a little 0 on top here. But let's pick numbers to the left and to the right of our critical numbers. In this case, we only have one critical number, and we have a number to the left, we have a number to the right. and determine the sign of f prime at x at those numbers. Well, I picked -3 because that's to the left of 0. I could have picked any number over here. If you plug in -3 to f prime, you get -6. Any number on this side of the critical number is going to give us a negative. So you see all these negatives I put here? That means the entire derivative on the left side of 0 is going to be negative. I picked 5 on the right side of 0. When you plug in 5 to the derivative, you don't get 25. That's my mistake. You get 10. So let me write that here. Sorry about that, because 2 times 5 is 10. So let me write 10 here. 10. And it's a positive 10. Any number I would have picked on this side would have given me a positive number. So I'm filling up this side with positives. All right. Ladies and gentlemen, here's the table again. It's the same table you saw. Since f prime of x is less than 0 to the left of 0, we say that f of x is decreasing. Okay? And since f prime of x is greater than 0 to the right of 0, we say that f of x is increasing. This is our justification for increasing and decreasing. Saying where the derivative is less than 0 is the justification for decreasing. Not, well, x is getting bigger, y is getting bigger, or y is getting smaller. That's a pre-calculus notion. The calculus notion is our derivative is negative, so our function is decreasing. In this same vein, since f is greater than 0, or f prime of x is positive, then it is increasing. Let's look at one more quick example. Let's look at f of x equals x to the third minus 3x squared. Now, first thing you want to do is you want to take the derivative. Well, the derivative, ladies and gentlemen, of this is 3x squared minus 6x. Then, to find all critical numbers, we're going to set it equal to 0. In this one, we have to factor out a 3x. Set both of those things equal to 0. In the first case, x is equal to 0, and then in the second case, x is equal to 2. We have two critical numbers here, ladies and gentlemen. Two critical numbers. When we draw our number line, we're going to consider those two critical numbers. Sorry about that. So let me highlight these real quick. The two critical numbers that we found were 2 and 0. These are our critical numbers. That's where the derivative is 0. Now, since I have two critical numbers, I pick a number to the left. I picked -2, but you could have picked -7 or -12. If you plug -2 into the derivative, you'll see that you would get 24. 24 is a positive number. That means all these numbers to the left of our critical number 0 would have given us a positive solution. So there we have that. In between our two critical numbers here, we have 1. I could have picked 0.5. I could have picked 0.75. I could have picked any number in between 0 and 2. Okay, 1.5. I picked 1. When I plug 1 into the derivative, I get -3. That means any number I would have picked in between 0 and 2 would have given me a negative derivative. And last but not least, I picked a number to the right of 2. I picked 5. Could have picked 4, 400, 4 billion. It really doesn't matter, because when you plug in any number to the right of 2, you will get a positive number. Well, look at this. We have positives, negatives, and positives. That should automatically indicate in your brain what is happening in terms of increasing and decreasing. And this is what happens. F is going to increase from negative infinity to 0, union 2 to infinity. So wherever there's positives, I'm looking at an increasing function. F decreases between 0 and 2 because it's negative between 0 and 2. When I say it's negative, F prime is negative between 0 and 2. And this is our justification. This is how we say this. Now, whenever we say this, we say, well, why is it decreasing? It decreases because the derivative is negative. It increases because the derivative is positive on this interval. Oh, by the way, notice that I'm using open intervals here. I'm not including the endpoints because at these critical numbers, the function is neither increasing or decreasing. It's 0. It's a critical number. All right. We will get to some more examples, of course, in class, but please review these notes, write them down, pause the video, rewind. Here's your homework for section 3.3. It's going to be numbers 1, 6, 7, 11, and 15. And of course, 7, 11, that is a comma in between there, so please put a comma in between there. Thank you if you said bless you. Please submit your work or your answers on Canvas, and have a good day.